So what's x? If the absolute value of x equals 3, what's x? Yeah, plus or minus 3. Okay? So that's straightforward. That's what absolute value is. Now, if we're thinking absolute value of x has to be less than 3. So let's think of it on a number line. What happens if I chose, and here's my 0. What happens if I chose 3? Would that be true? If I put a 3 in there, would that be less than 3? Nope. So let's put that as an open circle. What about if I did negative 3? Negative 3 would turn into a positive 3. Nope, that's not less than 3. What about 0? Would 0 be less than 3? Yes. What about negative 1? Negative 1, absolute value of negative 1 would be 1. 1 is less than 3, so that's going to work. So we're starting to see that I could have values in here. Well, let's just try, so say I chose negative 4. Absolute value of negative 4 is a positive 4. Positive 4 is not less than 3. So if I were to choose negative 4, that would not be shaded because that's not going to work. Okay, so absolute value inequalities, just like with inequalities, it represents a range of numbers that are going to be our solution set. And it depends on which direction our inequality is going. If we're saying the absolute value part's bigger, or we're having a number that's bigger, and we'll do more practice with that. But just as a warm-up, that it represents a range of solutions. Okay? Just a refresher, absolute value, we know, okay, it's going to be the positive, it's going to be the negative. But what that actually means is the distance from 0 on a number line. Okay, so the absolute value of x simply means that distance from 0. So when we had that as 3, it means I could go 3 to the left to get to negative 3, but I could also go 3 to the right to get a positive 3. So that's what absolute value means. It represents the distance from 0. And we could go on the positive side, and we could go on the negative side. All right. We're going to be working with k a lot today. So k just represents some number. So absolute value of x equals k simply means that if I were to graph this on a number line, here's my 0, I could go from negative k all the way to positive k. So I would say x is going to be plus or minus k. All right, and this might seem redundant, but what this is saying is if I put a negative k in here, I get k. Yep, that's true. If I put a positive k in here, I get k, and it's still true. So that's why I say x is plus or minus k, meaning if I put that in my absolute value bars for that x, it will still equal k as an output. All right, so let's look at actually solving absolute value. If I'm going too fast, tell me to stop. Just tell me to slow down. Tell me to back up. And I'm not going fast because we're short on time. We got plenty of time. So the absolute value of 5 minus 3x equals 12. So I know if I have in my absolute value bars, if I had a negative 12, that would equal 12. And also if I have a positive 12, that would equal 12. So I'm trying to get this in the absolute value bars to equal 12 and to also equal negative 12. So I'm going to write out two separate equations here. So I'm going to say, okay, this piece in my absolute value bars, the 5 minus 3x, I want to make that equal negative 12 for this one here. But then I also want to make this equal a positive 12. Okay, so I want you thinking, okay, how do I make these absolute value bars be 12 and negative 12? Okay, and then expression in the absolute value bars. How do I make that become 12 or negative 12? Because I know if I take the absolute value of either of those, I get my positive 12, which is what I want. Now I have two equations, and I can simply solve. So if I subtract 5, end up with a negative 3x equals negative 17, divide by negative 3, divide by negative 3. X would be 17 thirds as one solution. This other one, I'll subtract 5, so negative 3x then would be a positive 8, or a positive 7, sorry. Divide by negative 3, divide by negative 3. X would be a negative 7 thirds. So those are my two solutions for this absolute value equation. But again, what I want to get across to you is we're trying to make that expression be a negative 12 and a positive 12. If I can get it to that point, I know once I do absolute value, it's going to end up being my positive 12 that I want. And again, absolute value, there's no way to get a negative number as an output. If you ever saw one that said absolute value of negative 12 equals a negative 12, that is false. That will never happen. Okay, let's do another one now with more absolute value bars. So again, I'm trying to make this 5 minus 3x be x plus 6, but also be a negative of x plus 6. And be very deliberate with your parentheses on there, because I want a negative of all of that. Do not write this as negative x plus 6. It's a negative of all of that. And so really this is negative x minus 6. So again, I'm going to create my two equations. So 5 minus 3x equals now a positive x plus 6 to go with this one. And 5 minus 3x equals negative x minus 6 to go with that one. So now I have two equations that I can solve. If I were to add 3x, subtract 6, I'd end up with negative 1 equals 4x. Divide by 4, I'd end up with a negative 1/4 equals x for one solution. And my other one, if I want to keep going, so I'll add 3x to this one, add 3x, but now add 6 this time to both sides. I'll end up with 11 equals 2x. Divide by 2, I'll have 11 halves is equal to x. So that was kind of a crash course refresher on solving absolute value equations. Like I said, you did in Algebra 1, you did in Algebra 2. The biggest thing is that you want to get your expression to equal a positive and a negative of the whole thing. So it's a negative of that piece. So don't just write negative x plus 6. It's a negative of all of that. Now let's talk about inequalities. So this is something that you have not done, but it's just a little nuance to what we've been doing already. So absolute value inequalities. So again, when we did this absolute value of x was less than or equal to 3, we set up a negative 3, we set up a positive 3. These were open circles. And I would go in between there. Any number in there would work. Negative 2 would work. Positive 2 would work. Negative 1, positive 1, 0. Anything in between there would work. But my boundary points at negative 3 and positive 3 would not work. And so I would set it up something like that. Now let's just do it in terms of k. So if I have absolute value of x is less than k, it's going to be from a negative k to a positive k. Again, open circles and everything in between there. Right? This is one, put a star next to it, box this in. If you have an absolute value less than some k, it's always going to be that section in between. So it will always look like this. Now let's take a look here. What happens if I said absolute value of x greater than 3? So that'd still be from negative 3 to a positive 3, open circles at each. Let's think of numbers. If I put in there 1, it's not going to work. Absolute value of 1 is 1. 1 is not greater than 3. But if I chose like 5, absolute value of 5 is greater than 3. So I know I'm going to be shading out. If I chose negative 5 works. So I'm shading out again. So in general, if I have the absolute value that's greater than my k, I'm going to be shading out. Okay, so like I said, in your notebook, I would box, star, something to know these two for sure. That if my absolute value is less than k, it's that chunk in between. If my absolute value is greater than k, it's going to the outsides. And we could think of these as a compound inequality. Let's just write these out. And so this would be a negative k is less than x is less than k. This inequality would be x values less than negative k or x values greater than k. I'd include that in your box or do another box around that if you haven't. Okay, so those go together. It's a compound inequality to represent what's happening on our number line. All right, so let's actually solve one. So 2x plus 1 is less than 7. So again, we're going to get some range of values here. We're not going to just get a number. We're actually going to get some range of values. Okay, first thing I am going to recognize is this is taking the form of my absolute value that's less than k. So I know it's going to be that chunk in the middle. That's going to be my solution set. All right, for this one, my x that we were working with is 2x plus 1. My k is 7. So that compound inequality we did a second ago said negative k has to be less than x, has to be less than a positive k. So this one we could set up, and this is going to be negative 7 is less than my expression 2x plus 1 is less than a positive 7. We haven't done any solving yet. Like I said, this is the stuff you have to know to be able to get to the point where you can solve. And it follows that pattern. If it's absolute value of x less than k, it's going to be this compound inequality where x is going to be in the middle. Identifying, well, really, x is my expression 2x plus 1 for this problem, and my k is 7. Now, to solve these compound inequalities, remember, we can break this up. We'll do this one first. Negative 7 less than 2x plus 1. So if I were to solve that, I'd subtract 1, I'd have a negative 8 is less than 2x. So negative 8 halves is less than x. And so this is negative 4 is less than x. That's my first answer. Now I also am going to focus on this right side of the compound inequality and do that. So 2x plus 1 has to also be less than 7. So if I subtract 1, I end up with 2x is less than 6. Divide by 2, x is less than 3. So I know x has to be greater than negative 4, but also x has to be less than 3. So my final answer on this one, I could write as one single inequality of negative 4 is less than x is less than 3. That would be my absolute final answer. Going all the way back to the beginning, solve, tell me what value of x will work so that the absolute value of it would be less than 7. If x is between negative 4 and 3, it will work. Okay, but this stuff here in black, this is the setup. We have to know this relationship to be able to create our compound inequality, split those into 2, and solve. Okay, let's do it the other way. So now, absolute value of 2x plus 1 is greater than 7. So now I can think of this, well, this is really absolute value of x greater than k. And if I know the absolute value of x is greater than k, so again, when we did our number line, it's going to be negative k to k. But now we're going to be shading outside on each one. And so this is going to be x is less than negative k, and x is going to be greater than a positive k. Again, we have to know these relationships to be able to continue on. From here, I can identify, well, really my x in this problem is 2x plus 1. My k in this problem is 7. So now I can start filling in. So 2x plus 1 has to be less than a negative 7. So if you don't follow this roadmap, there's a good chance you're not going to recognize that this actually has to be negative 7. Okay, and it becomes negative 7 because remember, we're going left of negative k. My k was 7, so it's actually less than negative 7. But then I also know that 2x plus 1 has to be greater than a positive 7. So there we've taken care of the absolute value stuff. Now we have an inequality that we can solve. Subtract 1. So 2x is less than a negative 8. Divide by 2. X is going to be less than negative 4. Second one, subtract 1. 2x is greater than 6. Divide by 2. X is greater than 3. So if I were to graph these solutions, I'm going to be here at negative 4. I'm going this way. Positive 3. I'm going this way. These are open circles. As an inequality, or not even, let's do it in interval notation. This is saying negative infinity all the way to negative 4 with parentheses around each, because we're not going to include the negative 4, union with 3 to infinity. Or if you left them as an inequality, you would just write or between these two. So x has to be less than -4, or x has to be greater than 3. I could graph it and show that. I could write an interval notation and show that. One more and then we'll be done. So absolute value of 2 minus 7x minus 1 is greater than 4. Whenever you're solving absolute value equations or inequalities, you want to get the absolute value by itself. You don't want anything with it. All right, so we want to add 1 to both sides here. So I have absolute value of 2 minus 7x is greater than 5, and now I will start. Same thing if you had a multiplication in front of your absolute value symbol. Say it was 5 times the absolute value of 2 minus 7x. Divide that 5 out. Get that out of there. You do not want to start solving until you get the absolute value by itself on one side. You got to do all your order of operations to get it by itself. Okay, so this is absolute value of x is greater than k. So am I shading between the k's or to the outside of the k's? Outside. Okay, and so really this is going to be now 2 minus 7x, and then I'm going to be going, well, let's just write it out. So if I'm going outside of these, these are open going this way. I want values of x that are less than -7. Well, we'll just say -k for now. And then this way, I want values of x that are greater than k. I keep writing 7. So this is 2 minus 7x is less than a -5. And then 2 minus 7x is greater than a +5. And it's easy to get these signs mixed up. Okay, it's easy to get if it's positive or negative, but also the inequality symbols, get those mixed up. That's what I'm saying. If you know this quick little number line, just draw it quickly in terms of x and k, you can go from there, and it's easier to solve, and you don't get mixed up. All right, so if I subtract 2, -7x is less than a -7. Divide by -7, divide by -7. Alarm should be going off in your head to reverse that inequality symbol. X is greater than 1. This side, subtract 2, -7x is greater than 3. Divide by -7, divide by -7. I divided by it, so I know I need to reverse this inequality symbol. So I have x is a -3/7. So this one kind of reversed itself a little bit. I have -3/7, and I want to go less than, so I'm going this way. I have 1, and I'm going this way now. Interval notation tells me I can write it as a negative infinity to a -3/7 with parentheses around each. And then 1 to infinity. I'll say it again. Know this number line in terms of x and k. Write that out, and then you won't get messed up. Okay, so 1.8, day 1 is in Math Excel. Closes Sunday at midnight. Okay? Closes Sunday at midnight. Oops. Make sure you have it done. Do not come into school Monday and think you can do it during second hour or third hour, because it will be closed. Okay? You still have 12 minutes today. You can probably knock out a couple of them.
Wait, so when is that due again?
Sunday nights. Sunday night at midnight. Okay? Write that in your planner. Write it on your arm. Do not forget Sunday,
So, you know how you brought up we could write it this way or this way?
depending on what Math Excel asks. If they want an interval notation, we got to do it this way. If they want it as an
Oh, so
equality,
I will
they'll
ask.
probably say interval notation more
Okay.
than anything else.
Okay, thanks.
You're welcome.